Welcome to The Explainer. Today, we're talking about something that sounds like science fiction, a way to see the future. But we're not talking about lottery numbers. We're talking about something way more important, predicting when things are about to break. So let's just jump right in with a massive question, one that engineers and doctors have been wrestling with for, well, forever. What if you could actually predict a failure before it happens? How do you stop a disaster that you can't even see coming? Everything eventually breaks down. Think about it. The bridges we drive over, the planes we fly in, even our own bodies, they all have a breaking point. It's just a simple fact of life. And yeah, it can be a little scary. The real challenge here isn't just knowing that things fail. We know that. It's predicting exactly when and why. For decades, right, we've had our traditional methods, scheduled checkups, statistical models, but they can only do so much. They often miss those really subtle hidden signs. The unseen cracks that can lead to total disaster.
Okay, so what if there was a better way? Well, there is. A totally new approach is changing the game, and it's called artificial intelligence. You can think of it as our new digital lookout, like an early warning system on steroids.
These AI models are basically like digital detectives. They can just turn through massive amounts of data. We're talking temperatures, vibrations, error logs, you name it, and find these hidden patterns that signal a failure is coming. Clues that are literally invisible to us.
And look, this isn't just some abstract theory. This is happening right now. For example, some researchers recently built an AI to go through all the maintenance data for the Brazilian Air Force's aircraft.
And the results? They were absolutely stunning. The AI hit a 95.8% F1 score. Now, that's a pretty technical term, but it's basically a really smart way of measuring accuracy. The point is, it could make sense of all these super complex maintenance records way better than anything they'd used before.
Okay, but it's not just about airplanes. Check out this next number. On the ground, researchers used a specific kind of AI. It's called a recurrent neural network, which is amazing at spotting patterns in data over time. And they used it to try and predict failures in our power grid. And what did they find? It hit over 97% accuracy. How? By picking up on all those tiny, subtle signals of decay, the things that build up over time right before a big, catastrophic power failure. Seriously, the applications for this stuff are just exploding. We're seeing it used to predict thermal system failures in EVs, to help classify heart failure patients so they get treatment earlier, even forecasting when submersible oil pumps might break, or detecting tiny wire breaks in our water pipelines. It's everywhere. But, with all this incredible power comes a pretty big challenge. And it all boils down to a single question. Trust. Let me ask you this. If an AI predicts a jet engine is about to fail, but it can't tell you why, would you ground the plane? That right there is the heart of the infamous black box problem. These incredibly powerful AI models, they give you an answer, but they often can't explain their own reasoning. And when the stakes are that high, a prediction without an explanation, that's just a huge gamble. So you see, there's a huge difference between the what and the why. Getting the prediction, that's the what, is definitely useful. But it's the why, the explanation, that's absolutely essential. That's what gives us the confidence to actually trust it and, do something about it. And this is exactly why a whole new field has popped up called Explainable AI, or XAI for short. Its entire mission, its whole reason for being, is to crack open that black box. To make the AI's decisions transparent so that we humans can actually understand and trust them. So that brings us to the big question. How do we get the best of both worlds? How do we get that insane predictive power of AI and the trustworthy explanation we absolutely need? Well, the answer isn't about choosing one or the other. It's about bringing them together.
And that's the real cutting edge here. It's not about AI just replacing all the old methods. No way. It's about fusing AI with them. Instead of throwing out decades of engineering and statistical knowledge, we can use AI to completely supercharge it.
Let's break it down. You've got your classical models, right? They're based on physics, totally explainable, but kind of rigid. They can't handle really complex data. Then you have the pure AI models. They're amazing at finding hidden patterns, but they're that black box we talked about. But a hybrid model, well, it combines the two, giving us the strengths of both and pretty much none of the weaknesses. It's the best of both worlds. And the way it works is actually pretty brilliant. You start with a trusted classical model, something based on engineering or statistics that we already understand. Then you augment it with tons of real-world data. And that's when you let the AI loose to find all the complex, hidden patterns in that data that the old model just couldn't see. What you get at the end is a supercharged prediction that's both incredibly accurate and explainable. And this isn't just a concept. People are doing this right now. Researchers are taking classic engineering ideas like stress strength models, which really just ask a simple question. Can this part handle the load it's under? And they're enhancing them with machine learning. They're using AI to help understand how all these different factors are connected and, crucially, to get a way better handle on uncertainty.
All right, so let's zoom out. What does all this mean for the future of prediction? Because this is more than just a cool tech upgrade. We're talking about a fundamental shift in how we manage the really complex, really critical systems that our whole world runs on.
This move toward hybrid AI, it means safer travel, more reliable infrastructure, better medical outcomes. Think about it. An engineer doesn't just get a blinking red light for a jet engine anymore. Now they see exactly which part is under stress and why. That means safer planes for us, more reliable power grids, and doctors who can step in way earlier and with a lot more confidence. Okay, so let's wrap this up. If you're going to remember just 3 key things from our little explainer today, make it these. First, AI is incredibly powerful at spotting complex failure patterns in data. Second, for the really critical stuff, a black box prediction just isn't good enough. We absolutely need to know why. And third, the future is hybrid. It's all about combining AI's raw power with the trusted logic of classical models. And that really leaves us with one final big question to think about. Now that AI can predict when things are going to break, what are we going to do with that knowledge? I mean, having the power to see failure before it happens is one thing. The real question is, how will we use that amazing foresight to build a safer, more resilient world for everyone?